Hello friends, welcome to my channel. In this video, I am going to discuss about orthogonality of complex function. Before going to start orthogonality property of complex function, let's understand what is orthogonality. Orthogonality is to be perpendicular to each other. That means if I say two vectors are orthogonal to each other, means they are perpendicular to each other. If I say two curves are orthogonal to each other, or two lines are orthogonal to each other, that means they are perpendicular to each other. So let's start the complex function. The complex function is written in the form of u plus iv, where both u and v are two independent curves h. U is equal to f of 1 xy, v is equal to f of 2 xy. As we all know that complex function, that is a function of complex variable, is written in the form of u plus iv, where u and v are two independent functions of variable x and y. So as you can see, I have drawn an xy Cartesian plane on which I have drawn two curves, one for u and second for v. Now draw respective slopes of these curves named m1 and m2. Now, to check the orthogonal property, we have to check whether the slopes of curves are perpendicular to each other or not. If the slopes are perpendicular to each other, then the curves are automatically perpendicular or orthogonal to each other. Then we will prove our statement or prove our orthogonality property of complex function. To check the orthogonality, we have to show that m1 multiplied by m2 is equal to minus 1. So there are a formula to check the orthogonal property of two curves or two lines, that if the slopes of the lines are perpendicular to each other, then the lines or the curves are automatically perpendicular to each other or orthogonal to each other. So as you can see here, I have written here, to check the orthogonality, we have to show that m1 multiplied by m2 is equal to minus 1. That is, m1 and m2 are slopes of respective curves. That is, m1 is slope of u curve and m2 is slope of v curve. So now, differentiating u and v with respect to x and y partially, or by writing the differential equation of u and v, we get del u by del x dx plus del u by del y dy is equal to 0 for the differential equation of the curve u. Second, let's write the differential equation for the curve v, that is del v by del x dx plus del v by del y dy is equal to 0. Now, let's derive the slope of respective curves by using these differential equations. So, m1 is equal to dy by dx. Del u by del x dx plus del u by del y dy is equal to 0. From this equation, let's change the position of this term to the RHS of this equation. Then we get del u by del x dx is equal to minus of del u by del y dy. Now, let's change again the position of del u by del y along with minus sign to the LHS of this equation. Then we get del u by del x divided del u by del y along with minus sign, and change the position of dx to the RHS of the equation also, that is to the denominator of dy. Then we get minus of del u by del x divided by del u by del y is equal dy by dx. Let the equation be named as equation 3. Similarly, derive dy by dx, that is slope m2 for the curve B. From equation 2, that is the differential equation of curve B, then del V by del X dx plus del V by del Y dy is equal to 0. I have written this equation already here. Now, from this equation, let's change the position of the term del V by del Y dy to the RHS of the equation. Then we get del P by del X dx is equal to minus del P by del Y dy. Now, again change the position of the term minus del V by del Y to the LHS of this equation. Then we get minus of del V by del X divided by del V by del Y is equal to dy by del X dx. Here I have changed the position of dx to the RHS of the equation also. So let this equation be named as equation 4. So as per the orthogonality condition, we have m1 multiplied by m2. Now write the value of m1 and m2, that is dy by dx for curve u and dy by dx for curve 2, and multiply them. So I have the value m1, that is minus of del u by del x divided by del u by del y multiplied by the slope of b, that is del v by del x divided by del v by del y along with the minus sign. Now multiply them. Before going to multiply, let's change the terms of m2 using the CR equation. CR equation says that del u by del x is equal to del v by del y and del v by del x is equal to minus del u by del y. Now change the terms using this CR equation of m2, slope number 2, that is del v by del x can be replaced by minus of del u by del y. So I have replaced del v by del x by minus du by dy or del u by del y divided by del v by del y also replaced by del u by del x. So I have replaced this by del u by del x. So now we get minus of del u by del x divided by del u by del y multiplied by del u by del y divided by del u by del x. Now you can see here I can cancel out the del u by del x to the del u by del x and del u by del y to the del u by del y. By cancelling, I get the answer minus 1, that is m1 multiplied by m2 is equal to minus 1, that is the multiplication of slope of two curves, that is curve of slope of u and slope of v is equal to minus 1. It satisfies the orthogonality property of two curves. So by the following this method, we have solved our